Okay, this is a detailed solution of the test 2 study guide. I'm going to begin with question 1. Classify the following random variable according to whether it is discrete or continuous. The number of bottles of juice sold in a cafeteria during lunch, so number of bottles. Well, we can count the number of bottles, 0, 1, 2, 3, etc. So that must be discrete. And that's it. You select the answer and you move on. Number 2. Okay, number 2. Given the table of probabilities for the random variable x, does this form a probability distribution? For probability distribution, guys, you know that each probability must be between 0 and 1, and the sum of probabilities should add to 1. Well, you notice that the probability of x equals 10 in the table is a negative number. You can see here probability of x equals 10 equals negative 0.3. So that's a violation to the definition of probability distribution. So the answer is no. Not a probability distribution. Do you need to add the probability and see if they are 1? Not anymore, because it did not meet the first condition. You do not need to check the second condition. Number 3. A manager asked her employees how many times they had given blood in the last year. The results of the survey are given below. The random variable x represents the number of times a person gave blood, and px represents the probability of selecting an employee who had given blood that percent of the time. What is the mean number of times a person gave blood based on this survey? The mean is by definition sum of x px. So what I'm going to do here, I'm going to put in the formula. We're going to begin with 0. When x is 0, what's the probability of x equals 0? It is, so probability of 0 plus 1 times probability of 1 plus 2 times the probability of 2. We have a plus all the way to what? Plus 6 and times probability of 6. Okay, so the answer will be 0 times what? 0.3 plus 1 times 0.25 plus 2 times 0.2 plus 3 times 0.12. I'm reading the values of the table. Plus 4 times 0.07 plus 5 times 0.04 and plus 6 times 0.02. You guys, you just plug in the values into the calculator and get the answer. It turns out to be 1.60. Number 4. A dice game involves throwing 3 dice and betting on one of the 6 numbers that are on the dice. The game costs $12 to play, and you win if the number you bet appears on any of the dice. The distribution for the outcomes of the game, including the profit, is shown below. So number of dice with your number 0, 1, 2, 3, and then this is the profit and the probability of observing. Find the expected profit from playing the game. The expected profit, guys, is the same as the mean of the probability distribution. So E of x is sum of x, P of x. Okay, let's do that. X is the amount of gain or loss, so it is the profit, and the probability of observing is P of x. So it's going to be negative 12 times 125 divided by 216 plus 12 times 75 divided by 216 plus 14 times 15 over 216 plus 36 times 1 over 216. If you do the math, you just multiply negative 12 times 125 plus 12 times 75 plus 14 times 15 and then plus 36 times 1 and then divide the whole thing by 216. You will get this answer, negative 1.69. What does the answer mean? It means for every ticket you play, you expect to lose $1.69. Why don't you lose the entire $12 that you play? Because you have a chances of winning. So that's what the expected value means. Okay, next question, 5. In the American version of the game roulette, a wheel has 18 black slots, 8 red slots. So we have 18 black, 8 red, and 2 green. All slots are the same size. In a carnival game, a person wagers $2 on the roll of 2 dice. So you pay $2. A person can wager on either red or black. Green is reserved for the house. If a player wagers $5 on either red or black and the color comes up, they win $10. Otherwise, they lose their wager. What is the expected value of playing the game once? So if you roll 2 dice and you get the same color, either black or red, you would win. So if you get red or black, you would be a winner. Otherwise, you would lose. So let's figure out the probability distribution table, and then from that we can do the expected value. There's one thing in this exercise that they added the 2 that should not be there. I have to just double check on that. But anyway, so if a player wagers $5 on either red or black and that color comes up, they win $10. Otherwise, they lose their wager. What is the expected value of playing the game once only? So if you win $10 but you already paid $5, so you're gonna lose $5. So I'm gonna do probability of winning and probability of losing. Probability of winning, you will get $5. This is the gain. Okay. What is the probability of getting 2 reds? Well, we have 8 red out of 28, so it will be 8 over 28. But there is another die, so there will be another 8 over 28, and you multiply the 2 probabilities. But you also win $5 if you get black. What is the probability of getting a black? It's 18 over 28 times 18 over 28. You would lose if you don't get red or black. So it's gonna be, let me write it down here, -5. You would lose your $5. What's the probability of losing? Well, we have the probability of winning. The probability of losing will be 1 minus the probability of winning. So I'm just gonna do 1 minus 8 over 28 times 8 over 28 plus 18 over 28 times 18 over 28. So in order to find the expected value, you just do this. E of x equals sum of x px, which is 5 times 8 squared over 28 squared plus 5 times 18 squared over 28 squared minus, so plus the probability of losing now, -5 times 1 minus 8 squared over 28 squared minus as well, so plus 1 minus 18 squared over 28 squared. It's a lot of math and calculator use in this problem, but that should give you the answer. And that I should have put here 1 minus here. Alright, so that's number 5. You just do the math and compute the answer. Number 6. The random variable x represents a number of girls in a family of 3 children. So n is 3. Assuming that boys and girls are equally likely, so probability of having a boy or a girl is a half, so which is 1 over 2. Find the mean and the standard deviation of the random variable. Well, this is a binomial experiment. The number of trials is 3 and probability of success is 1/2. So the mean is NP and the standard deviation is square root of NPQ. P is the probability of success and Q is the probability of failure, and Q is 1 minus P. So for the mean you just do 3 times 1/2, which is 1.5. And for the standard deviation you just do square root of NPQ, so 3 times 0.5 times 0.5, which is, 0.5 here. Square root of 0.75, and if I use the calculator, 0.75 and take the square root of this one, it will be about 0.237. So that's number 6. Number 7. Yeah, I just noticed that I plugged in the wrong number in the calculator. Actually, square root of 0.75 turns out to be 0.87. You can check that on the calculator, guys. Number 7, decide whether the experiment is a binomial experiment. If it's not, explain why. Testing a cough suppressant using 440 people to determine if it is effective. The random variable represents the number of people who find the cough suppressant to be effective. Okay, we have a fixed number of trials, which is the maximum number is 440. So that's the first condition of the binomial experiment. People are going to say it's either effective or not effective. So we have a success or a failure. So that is the second condition, which is met. And the third condition, that the probability of success does not change from one person to another. And since all those people are different people, so that will not change. So this is a binomial experiment. So probability of success does not change from one person to another. We're expecting people here to say it's either effective or not effective. So we have either success would say, let's say, assume it is effectiveness, so then failure will be not effective. So it is a binomial experiment. Number 8. In a recent survey, 61% of the community favored building a health center in their neighborhood. So the probability of success, guys, is 61%. And if 14 citizens are chosen, so n is 14. Once the problem begins with a percentage, you can suspect that this is going to be a binomial problem. Find the probability that exactly 5 of them favor the building of the health center. So we need a probability of x equals 5. If you guys are using technology, you must write it exactly like I'm doing this. So you're going to go to the calculator and find out this function binom PDF. And then you're going to put the value of n, you're going to put the value of p, and you're going to put the x value, which is given in the problem. So this is going to be binom PDF, n is what? 14, p is 0.61, and x is 5. How would you use the calculator to do this? You would go second press the second key, then you press the variable key, and then you scroll down until you get to the letter A, I believe, which is binomial PDF. Then the calculator is going to ask you for the number of trials. You enter that. If you have a newer calculator, then the probability of success, you're going to enter 0.61. Then the number, the x value, which is 5, and then you paste it, and then you will see exactly the formula that I just put there. And then you press enter, and you should get your answer. If I do that on the calculator, if I'm going to input 14, and then it will ask me for P, so I put 0.61. Then the X value I put 5, and then paste, and then press enter again. And that should give me, let me write those, 0.615, and I'm going to ask you to round your answer to 4 decimal places, so this will be 0.0353. Okay, let's go to the next number, number 9. The probability that a house in an urban area will develop a leak is 5%, so probability of success is 5%. You can write it as a decimal, 0.05. If 28 houses are randomly selected, what's the probability that none of the houses will develop a leak? So n is 28, and what is it that he wants? He wants a probability of x equal to 0. Okay, how are we going to do this? Probability of x equals 0. It's the same way that I did the previous exercise. Binomial PDF n px. So that will be binomial PDF. N is, what did we say, 28. P is 0.05, and x here is 0. So if I try to do the math, guys, here, so I'm using the calculator. I'm entering the value of n, 28. Then I'm entering the probability of success, 0.05. Don't put 0.5 there, and then I'm putting 0 for the x value, and the answer is 0.2378. Next one, number 9. The probability that a house in an urban area will develop a leak. No, sorry, that's number 10, I believe. Yeah, number 10. According to government data, the probability that an adult was never in a museum is 15%, so P is 15%. In a random survey of 10 adults, N is 10. What is the probability that 2 or fewer were never in a museum? So 2 or fewer. How would you express that as an inequality? It is less than or equal to 2. So he wants a probability of x less than or equal to 2. Your calculator can do this. Less than or equal, we can do it on the calculator. And the formula for that is the binomial CDF. So the CDF is reserved only for less than or equal to. You enter the value of n, then enter the value of p, and then you enter the value of x. How do you access this one? You go to second, variables, and scroll down until you find binomial CDF. You fill in the values, 1 for n, 1 for p, and 1 for x, and press enter, and then you get the answer. So this is what I expect you to write exactly on the test. You have to write the formula, binomial CDF, and then n is what? 10. Probability of success is 0.15. Don't put 15, you have to change it to a decimal, and then you put 2, which is equal to what? Let me just do this quickly. Second variables. I'm doing it in real time as I do this. So number of trials, which is n. When you see trials, that's n. So you enter the value of n, 10. Then p, you enter 0.15. and then the X value you enter 2, and the answer should be 0.8202. Alright, let's move to the next question, 11. A recent survey found that 70% of all adults over 50 wear sunglasses for driving, so probability of success is 70%. In a random sample of 10 adults over 50, so N is 10. What is the probability that at least 6 wear sunglasses? Okay, at least 6. At least 6, guys, means greater than or equal to 6. So you have to write probability of X greater than or equal to 6. Which is? You can do the binomial PDF, but greater than or equal to 6 means the probability of X equals 6, or 7, or 8, or 9, or 10. If you use the binomial PDF, you would have to do it 1, 2, 3, 4, 5 times, which is a lot of work. So I'm going to show you a way you can do it in less time and using a shortcut. Okay, the possible values of the random variable, since n is 10, it goes from 0 to 10, all the way to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do we want? We want it from 6 and up, so we want this. And the remaining part we do not want. But the remaining part I can find its probability using the binomial CDF, because this one is a probability of X less than or equal to 5. 5 and less. I can find this one using binomial CDF, N is 10, 0.70, and then 5. And whatever answer I get, I can do 1 minus to find the probability of X greater than or equal to 6. So because the sum of probabilities is 1, so probability of X greater than or equal to 6 equals 1 minus binomial CDF 10, 0.7, and then 5. And that will be 1 minus, let me just do this quickly. You'll get 1 minus 0.1503, and the final answer, guys, will be 0.8497. 12. According to Federal Communication Commission, 70% of all U.S. households have VCRs. Well, it's not the case anymore, so that must be an old question. In a random sample of 15 households, what's the probability that fewer than 13 have VCRs? So probability of success is 70%. How many did we survey? N is 15. And he says fewer than 13. What is fewer than 13 means? Means less than 13. So what's less than 13? It's a 12 because it's discrete. So it's whole numbers. So probability of X less than 13 is the same as probability of X less than or equal to 12. Now why did we need to shift it to less than or equal to 12? Because we can use the binomial CDF. So that will be binomial CDF, and then you put the value of N, which is 15, probability of success, which is 0.70, and then you put 12, not 13 here, and then you do the math. Let me see that. That will be 15, 0.70, and then 12, and the answer is 0.8732. Alright, next. 13. A recent survey found that 80% of all adults over 50 wear sunglasses, so P is 0.8 for driving. in a random sample of 50 adults over 50. So n is 50. What is the mean and what is the standard deviation? Where the mean, guys, is NP for the binomial distribution. It's very easy to compute. It's 50 times 0.80, which is what? 40. And the standard deviation is square root of NPQ. Q is 1 minus P. So that would be what? Square root of N, which is 50, times 0.80. And what's 1 minus 100% minus 80% is 20%. So that would be, let me compute this, 50 times 0.8 times 0.2. And don't forget to take the square root of this. It will be 2.83. All right. So I'm gonna pause here and post this portion of the video as the first part covering the binomial probabilities, and then on the second video I'll do the rest of the exercises.